Something is happening in the Pacific Ocean right now that has never happened before in recorded history. And when scientists say never, they do not mean never in the last decade or never in the last century. They mean never since humans began systematically measuring ocean temperatures. Never since satellites started watching the equatorial Pacific. Never in any dataset that goes back further than the mid-1800s. What is unfolding right now in the waters stretching from the coast of Peru all the way to south of Hawaii is so far outside the historical envelope that the models themselves keep having to be revised upward because reality keeps outrunning the forecasts. This is not a typical El Nino. This is not even a strong El Nino by the definition scientists have used for decades. What this is, based on every metric being measured right now in August of 2026, is something that may not have a name yet, because nothing we have ever seen before prepared us for numbers like these. And before this video is over, you are going to understand exactly why every major climate research institution on the planet is paying very close attention to what is building in the Pacific right now, and what it means for the winter that is coming. To understand the full weight of what is happening, you first need to understand what El Nino actually is and why it matters so much. The Pacific Ocean is the largest body of water on Earth. It covers more surface area than every landmass on the planet combined. And sitting along its equator is a system of winds, ocean currents, and heat exchanges that essentially acts as the thermostat for global weather. Under normal conditions, powerful trade winds blow steadily from east to west across the equatorial Pacific. Those winds push warm surface water westward, piling it up near Indonesia and the Philippines, while colder water wells up from the depths along the South American coast near Peru. This system stays in a kind of dynamic balance. The warm water stays in the west, the cold water dominates the east, and global weather patterns organize themselves around that arrangement. But periodically, that balance breaks down. The trade winds weaken. The warm water that had been piled up in the western Pacific sloshes back eastward. Cold upwelling off South America gets suppressed. Sea surface temperatures across the central and eastern equatorial Pacific rise dramatically. And when that happens, the entire global atmospheric circulation reorganizes itself in response. Jet streams shift, storm tracks relocate, droughts intensify in some regions while catastrophic flooding develops in others. Entire seasons worth of weather across multiple continents get rewritten. That is El Nino. And the stronger it is, the more violent and widespread those consequences become. The events of 1982 and 1983 gave the modern world its first real understanding of how destructive a major El Nino could be. That event, which at the time was the strongest on instrumental record, drove catastrophic flooding across Peru and Ecuador, severe droughts across Australia and southern Africa, devastating wildfires across Indonesia, and a completely disrupted winter across North America that left a multi-billion-dollar damage footprint. Then 1997 and 1998 arrived and shattered every record that 1982 had set. The 1997 El Nino was so powerful that it caused global average temperatures to spike, contributed to some of the most destructive weather events of the late 20th century across every inhabited continent, and reshaped scientific understanding of how extreme these events could become. California was hammered by atmospheric river after atmospheric river. The southeastern United States flooded repeatedly. Australia baked under historic drought. The global economic damage ran into the tens of billions of dollars. Scientists walked away from that event believing they had now seen the ceiling of what El Nino could produce. Then 2015 produced another very strong event. Then 2023 surprised forecasters with its rapid intensification. And now August of 2026 is showing something that makes every one of those events look like a warm-up act. The sea surface temperature readings across the equatorial Pacific right now are extraordinary by any historical standard. The Pacific is divided into monitoring regions that scientists use to track El Nino development with precision. The Nino 4 region, covering the central equatorial Pacific, is sitting at 1.15 degrees Celsius above average. The Nino 3.4 region, which is the primary basin that scientists watch most closely because it has the strongest connection to global atmospheric response, is running at 2.62 degrees Celsius above average. That reading alone would place this firmly in strong El Nino territory by any definition used in modern meteorology. The Nino 3 region is at 3.23 degrees above average, and the Nino 1+2 region, sitting closest to the South American coast off Peru, is at 23 degrees Celsius above the historical average, 4.23 degrees, in early August. That is not a number that fits comfortably inside any historical framework scientists have built for understanding this phenomenon. When you look at the raw sea surface temperature maps without the anomaly calculations, you see water south of Hawaii running between 30 and 31 degrees Celsius. That is 86 to 88 degrees Fahrenheit, sitting in the open equatorial Pacific, in a location where those temperatures have no business existing at this point in the year. The suppression of cold upwelling off the Peruvian coast is almost complete. Sea surface temperatures along the south. American coastline that are normally kept cool by that upwelling are also running in the 80s Fahrenheit. The eastern and central equatorial Pacific has essentially transformed into an enormous bathtub of anomalously warm water stretching thousands of miles from the coast of South America to south of Hawaii. But the surface temperatures, as record-breaking as they are actually not the most alarming part of this story, because this is not just a surface phenomenon. The heat goes deep. Normally, when you measure ocean temperature at increasing depths, you find a straightforward and predictable pattern. The surface is warm because sunlight heats it. Below a certain depth called the thermocline, temperatures drop sharply as sunlight can no longer penetrate effectively. Cold water sits in the deep ocean and warmer water floats on top. That is the fundamental structure of ocean thermal layers, and it has been consistent throughout the entire period of modern oceanographic measurement. Except right now in the equatorial Pacific, that structure has been completely inverted. Subsurface temperature anomalies measured hundreds of feet below the ocean surface are currently peaking at 10 degrees Celsius above average, 10 degrees, below the surface, in the deep water that is supposed to be cold. That represents a reservoir of thermal energy stored beneath the surface of the ocean that is so large, so deep, and so far above historical norms that researchers are struggling to find language that accurately conveys its significance without sounding like exaggeration. There's an almost incomprehensible amount of heat sitting below the surface of the equatorial Pacific right now. And it is slowly but steadily making its way toward the surface and eastward toward the regions where it will drive this El Nino to its peak intensity. This subsurface heat is being moved and reinforced by a mechanism called an oceanic Kelvin wave. A Kelvin wave is essentially a pulse of warm water that travels eastward along the equator below the ocean surface, driven by changes in wind patterns at the surface. When a westerly wind burst occurs across the equatorial Pacific, a burst where trade winds reverse direction and blow from west to east instead of east to west, it pushes warm water downward and eastward, creating a subsurface pulse of anomalously warm water that travels across the entire width of the Pacific over a period of weeks to months. The pulse then arrives in the eastern Pacific and rises upward, warming the surface temperatures further and reinforcing the El Nino. Right now, another significant downwelling Kelvin wave is in progress. The subsurface animation data from the last 11 days shows these anomalies visibly expanding eastward and deepening simultaneously. More warm water is being added to an already record-warm subsurface layer. The thermal climb index has gone historically negative. The fuel tank was already full, and more fuel is being pumped in. The surface temperatures are record-breaking, but what is sitting below the surface suggests the surface temperatures have not yet reached their maximum. Sea level heights across the equatorial Pacific are providing independent confirmation of everything the temperature data is showing. This is important because sea level measurements and temperature measurements are produced by entirely separate instrument systems using completely different physical principles. When warm water accumulates in a region of the ocean, it expands, taking up more volume and pushing sea levels higher. Right now, sea levels across the central and eastern equatorial Pacific are running significantly above average. Meanwhile, in the western Pacific, over Indonesia and the Philippines and Australia, sea levels are running below average because the warm water that normally sits there has migrated eastward. Two completely independent measurement systems pointing to the same physical reality. An unprecedented accumulation of warm water in the central and eastern equatorial Pacific with no indication that it is going anywhere except further east and further toward the surface. When the current readings are placed alongside every past El Nino event in the historical record, the picture that emerges is one that climate scientists describe with the kind of careful understatement that actually conveys how extraordinary the situation is. The Nino 1+2 region is recording its highest anomaly ever measured for this date in the calendar year, surpassing the benchmark events of 1997, 1982, 2015, and 2023 simultaneously. The Nino 3 region readings are also at all-time record levels for this point in the year, and approaching the highest values ever recorded at any point in any El Nino event in the modern instrumental record. The Nino 3.4 region, the one that matters most for global atmospheric response, is already sitting in Super El Nino territory in early August. In 1982, the event that until 1997 was considered the strongest modern El Nino, the equatorial Pacific on the same date was only showing weak El Nino conditions. It took months of additional development to reach the peak that caused such widespread destruction. In 1997, readings in early to mid-August were still only moderate to strong. In 2015 and 2023, the early August readings were well below what is being recorded in 2026. There is not a single past El Nino event in the instrumental record that was running as warm as the current event at this point in the calendar year. Not one. The ENSO longitude index, which tracks how far east the warm pool of water in the equatorial Pacific has migrated relative to its historical average position, is adding yet another dimension to this picture. During La Nina years, the warm pool sits firmly in the western Pacific, clustered over Indonesia and the Philippines, well to the west of the international dateline. During typical El Nino years, the warm pool migrates somewhat eastward past the dateline and into the central Pacific. But right now, in 2026, the warm pool has migrated so far east that it is sitting south of Hawaii. That is the furthest east the warm pool has ever been measured for this time of year in any year on record. When you plot the 2026 reading on the longitude index against every past El Nino event simultaneously, the 2026 data point sits completely isolated from the historical cluster, further east and warmer than any prior analog. It is not close to the previous record. It is in a category by itself. And why does that matter so much? Because the further east that warm pool extends, the more directly it impacts the atmospheric circulation patterns that govern winter weather across North America. The signal does not have to travel as far. It does not have to cross as much cold ocean before it reaches the regions that will reorganize storm tracks, redirect jet streams, and reshape what winter looks like for hundreds of millions of people. None of this ocean warming would translate into the catastrophic winter weather being projected if the atmosphere were not responding to it. El Nino requires ocean and atmosphere to couple together in a reinforcing feedback loop for its full potential to be realized. Right now, that coupling is happening at a strength that has never been recorded this early in an El Nino cycle. The multivariate ENSO index, which measures the strength of atmospheric response by synthesizing wind patterns, pressure anomalies, convective activity, and regional temperature departures into a single number, is currently sitting at 2.4. A score of 2.0 indicates a very strong El Nino atmospheric signal. A score of 2.5 is classified as exceptional El Nino territory. The 1997 event recorded a 2.3 on this index in early August of that year. The 2015 event recorded 1.8. The 1982 event recorded 1.7. The 2026 event is at 2.4, ahead of all of them. The atmosphere is not lagging behind the ocean on this one. It is matching the ocean step for step in real time. The Southern Oscillation Index, one of the oldest continuous climate measurement series in existence, is running at minus 21.72 over the last 90 days, with the 30-day average approaching minus 26. Values this strongly negative typically do not appear until September or even October in major El Nino years. They are appearing in early August 2026. The Walker circulation is not just weakened, but in multiple instances reversed, producing intense westerly wind bursts that actively push warm water eastward rather than allowing the natural trade wind system to restrain El Nino development. More westerly wind burst activity is forecast through the remainder of August. The system has its own momentum now, and that momentum is pointing in one direction only. The Madden-Julian oscillation is about to add another layer of forcing. The MJO is a globe-circling pattern of enhanced and suppressed rainfall completing one full circuit of the planet approximately every 30 to 60 days. Right now, the MJO is moving into phase 6, which places its area of enhanced convective activity directly over the Central Pacific, in a configuration that constructively reinforces the existing El Nino-based state. Both the European ensemble and the American GFS ensemble models are showing a coherent and amplified MJO phase, 6 signal developing through mid to late August, driving another significant pulse of westerly wind anomalies across the equatorial Pacific. The record subsurface heat reservoir is about to receive another injection of eastward pushing forcing. The system is not approaching stability. It is continuing to accelerate. Every major forecast model has been tracking this trajectory throughout 2026 and revising upward consistently. The European ensemble in January called for weak to moderate El Nino conditions by summer. By March, aggressive members were pushing into super El Nino territory. By June, the ensemble mean itself had moved into historically unprecedented ranges. The August 1st update shows an ensemble mean of 4.11 degrees Celsius in the Nino 3.4 region at the projected peak, with the highest individual ensemble members reaching 4.4 to 4.6 degrees in December. The American CFS model is showing every ensemble member above 3.8 degrees through the core winter months, with some members touching 5 degrees. The North American multi-model ensemble is projecting peak anomalies in some Nino subregions, potentially exceeding 6 degrees. The Canadian model is running members at 5.7 degrees. Every major modeling center on the planet, running independent models built on different assumptions and different computational approaches, is converging on the same conclusion. Scientists are beginning, with appropriate scientific qualification, to discuss the possibility that this event could approach or exceed the all-time record set in 1877, an event so extreme that it predates systematic ocean monitoring and is known primarily through historical accounts of catastrophic famine, crop failures, and weather anomalies across multiple continents simultaneously. What this translates into for the United States when winter arrives is a forecast that every major modeling center is treating with full seriousness. El Nino reorganizes the atmospheric circulation of the entire northern hemisphere during winter through mechanisms that are among the most well understood and reliably predictable signals in all of seasonal climate science. The Aleutian low deepens and expands southward. The subtropical jet stream, which in a normal winter does not regularly penetrate the interior of the continental United States, strengthens dramatically and extends its reach across the southern tier of the country, acting as a conveyor belt, delivering Pacific moisture repeatedly and relentlessly. The stronger the El Nino, the stronger the subtropical jet, and the more extreme the precipitation outcomes become in the regions lying beneath its path. California is going to bear the full weight of what a historically unprecedented subtropical jet delivers when pointed directly at the California coast for months. What the 1997 into 1998 El Nino did to California, the stacked atmospheric river events, the catastrophic flooding, the mudslides and debris flows, was produced by an event that current measurements already surpass. Every model is showing California as a primary target for extreme and potentially historic precipitation this winter. The flooding risk is real. Debris flow risk in areas carrying wildfire burn scars is serious. The Sierra Nevada snowpack could accumulate at rates not seen in decades, and the water infrastructure managing that runoff is going to be pushed to its limits. Across the Gulf Coast, from Texas through Louisiana, Mississippi, Alabama, and into Florida, the subtropical jet delivers moisture-laden storm systems producing persistent above-normal rainfall. All major modeling centers project significantly above normal precipitation across this entire region. The southeast, including Georgia and the Carolinas, also falls within the enhanced precipitation zone as the subtropical jet pushes moisture up the eastern seaboard. For the northeast, a powerfully enhanced subtropical jet loaded with moisture creates conditions for exceptionally intense storm events when cold air intrusions do arrive from Canada. The overall northeast winter temperature pattern during El Nino years tends to run warmer than average. But when cold air arrives into that moisture-rich environment, the resulting nor'easters can produce snowfall totals that would be historic even by the Northeast's demanding standards. For the northern tier of the United States and Canada, El Nino delivers warmer than average temperatures as the polar jet stream remains suppressed northward and cold air outbreaks become less frequent. Above average temperatures are projected across the northern plains, the upper Midwest, and much of Canada, with below normal precipitation across the Great Lakes corridor. The Climate Prediction Center has placed a 100% probability on El Nino continuing through the winter months, a 99% probability on persistence into early spring, and an 81% probability of this event qualifying as very strong through the peak months, with that number expected to climb with each successive update. These are not speculative assessments. They are high-confidence probabilistic forecasts issued at a point when the observational data is so overwhelmingly clear that the range of possible outcomes has narrowed to a degree unusual for seasonal climate forecasting. What is happening in the Pacific Ocean in August of 2026 is an event that redefines the upper boundary of what this climate phenomenon can produce. Record surface temperatures, record subsurface heat content at record depths, record atmospheric coupling, record warm pool eastward displacement, model guidance from every major center pointing toward peak values with no modern precedent, a subsurface fuel reservoir so enormous that the peak is still months away. The 1982 event reshaped understanding of El Nino. The 1997 event reset the ceiling. The 2026 event appears to be dismantling the ceiling entirely. The Pacific has been building toward something extraordinary for months. The winter of 2026 into 2027 is when the United States finds out exactly what that something is. यार स्क्रिप्ट फाइल में सेव करके प्रॉपर्ली काउंट करता हूँ, यार सीधा बात करता हूँ. इस ट्रांसक्रिप्ट में सिर्फ इतनी ही यूनिक इन्फॉर्मेशन है जो अप्रॉक्सीमेटली 3,800 वर्ड्स कवर करती है. अगर मैं 4,500 फोर्स करूँगा तो वही बातें रिपीट होंगी जो ऑलरेडी स्क्रिप्ट में हैं और क्वालिटी ख़राब होगी.